Okay, this week we will discuss and learn about how we can do the DC analysis for the BJT amplifier circuit. So this slide show the block diagram of the BJT amplifier circuit. So we have here the input for the amplifier is an AC input signal. So this is the function of an amplifier is to amplify the AC signal. So the input for the circuit should be the AC signal. So here we put is denoted as a V in. So this is AC input signal. And then at the output of the amplifier, there will be also an AC output, an AC signal. So denoted as a V out. Okay, so if the amplifier circuit have enough gain, so the output magnitude or amplitude should be bigger than the input. So thus we have this relationship between V out and V in. So V out should be bigger than V in for how much time? This is the AV. AV is the voltage gain. Okay, so the term of voltage gain has already covered in the previous class in the general amplifier model. Okay, and when we do this kind of analysis, BJT amplifier analysis, so usually we also need to consider the input and output impedance. So here Z in and Z out is also other parameters that need to be considered when we do the AC analysis. Okay, so and then there is also a DC part involved in amplifier circuit. This is where we power the amplifier, or in other words, we turn on the amplifier. So in order for an amplifier to operate properly, so the amplifier need to be powered. Okay, so in case of in case of the BJT based amplifier, so we need to make sure that the BJT is positioned at the suitable operating point, or we call it a Q point. So this is a Q point. So Q point means refer to the operating point. So the Q point here need to be in active operating region. So we have discussed about three main operating regions for the BJT. So we have active region, and then we have cut-off region, and we have saturation region. So in order for the BJT to operate properly or adequately as a amplifier, so the BJT Q point need to be in active operating region. Okay, so in specifically, the Q point actually refer to the value of IC and VCE. So we have ICQ, which means the collector current at the Q point, and VCEQ is a voltage cross collector emitter at the Q point. Okay, so how we can make sure that how we can set or position the Q point to be in certain operating point. Okay, so as I mentioned just now, the Q point actually refer to this ICQ and this VCEQ. Okay, so how we set this ICQ and VCQ at certain value, certain desired value. So this is done by using a bias circuit. So we have the bias circuit. Bias circuit is by arranging and by adding some resistor and some DC voltage in such way that we can control the ICQ and VCEQ. So there is many possibility or many type of bias circuit. The simplest one is called fixed bias. So fixed bias is where we add a DC voltage at the base. So this is base. So we add DC voltage VCC, and then between the VCC and base we have the current limiter resistor here. We call it RB. So and then emitter we is grounded for this collector. Collector is bias or is apply voltage VCC, and then there is a current limiter resistor called RC. So this is the simple fixed bias circuit. Okay, so another type of bias circuit, so we can also add resistor. Okay, add the emitter. So emitter we add resistor here. So the difference between fixed bias and the second type of bias circuit, we call it emitter stabilized bias. So this is by having emitter resistance RE, so it will stabilize the the bias operation. Okay. Okay. This the stabilizing the detail will be discussed later. So and then the third type of bias circuit that will be covered in this course is called voltage divider. So voltage divider. So if you compare the emitter stabilized with stabilized bias with voltage divider bias circuit, the difference is at the resistor network at connected to the base. Okay. So resistor at the collector and resistor at the emitter is same, but for the bias at the base, terminal, instead of having only one resistor RB, we have R1 and R2. So this is so the voltage that will be applied to the base will be the voltage division between R2 and R1. So because we apply here, this is VCC, this point is VCC, so the voltage here should be involve a voltage division between R2 and R1. So that's why it's called a voltage divider. So we have these three types that will be covered in this course: the fixed bias circuit, emitter stabilized bias circuit, and voltage divider bias circuit. So what is bias circuit? Bias circuit is used to set up the initial DC value of Q point. So the DC value of the Q point actually refer to the base current IBQ, collector current ICQ, and VCEQ, collector emitter voltage. Okay, actually this is the so-called complete amplifier circuit. So circuit amplifier circuit. Can you recognize the bias circuit? Okay, so bias circuit here, bias circuit used in this amplifier circuit is voltage divider. Okay, and then actually in this circuit, we have not only the bias circuit or amplifier, we also have some part which is we call it AC signal source. So we have this AC source and we have this resistor. These two components actually not belong to the amplifier circuit. This is the external element or component connected to the amplifier circuit. So this is AC signal source. And then so the AC signal source actually connected to the input of amplifier. So this is the input terminal. So this is the input terminal of the amplifier. So that's why we here we have plus at this point with respect to the ground here. This is VI. So this is the input voltage. Okay, and then the amplifier circuit, the output point is here. So this is the output point, and then the output point is connected to the, we call it a load. Okay, so the output signal will be measured across the RL. So the middle part is actually the actual amplifier circuit, and then now you can see the configuration used for the biasing the BJT is called voltage divider. Okay. So how you know this is voltage divider is by comparing this configuration or the arrangement of the resistor R1, R2, RC and RE with the previous slide. So this is voltage divider by circuit. Okay, and then you may notice there are three capacitors, but for now I will explain two capacitors, C1 and C2. So as I mentioned just now, the input of this amplifier circuit is here. So this is the input, and then the output is, this is the output. Okay, so actually the C1 is a capacitor that allow connection between this AC source, this is the AC source, or we call it a input signal, to the amplifier. So this connection between the AC source with the amplifier. So in between of the input port of the amplifier and the AC source, we have the capacitor. So this provide the connection, or we call it coupling. So coupling simply means connection. So this is make a connection. Okay, so this is C1, and the C2 is the capacitor that allow connection between the amplifier output port and the load. Okay, so this is how how the amplifier is connected to the AC source and to the load. So we have a capacitor coupling. So why we use the capacitor? Because the capacitor will allow the AC signal to pass through, and at the same time it will block the DC signal. So what does this statement means? So we can analyze the impedance of capacitor. So what is impedance of capacitor? So we have here the ZC is equal to 1 over J omega C. So C is the capacitor value, omega is 2 pi frequency. So you can see here the impedance of capacitor will depend on the frequency of the signal. Okay, so let's say we consider when the frequency is 0, or in other words, when frequency is 0 means the signal is in a DC form, direct current form. So when frequency is 0, so omega is 0. So what happened to the impedance of this one? So this will become a infinity. Okay, because the omega is 0, 1 over 0 is equal to infinity. So the capacitor here can be represented by the open circuit. Okay, so how about when the frequency of the signal is moderate or high? So when W is high, so we have the ZC will be near to the 0 ohm. So it's very small, very small, and then thus we can represent the capacitor with the short circuit. Okay, so this is why we say that for the signal, for the signal, for a DC signal, the DC signal will not going to pass the capacitor, so it will block. Okay. However, for the AC signal, it can flow across the capacitor. Okay.